Hi, the purpose of this video is to discuss using inverse and the zero product rule to solve a variety of equations that are known as rational equations. Rational equations are equations where we have variables in the numerator and variables in the denominator, as shown here. What I'd like to do is to demonstrate how the order in which we apply inverses will not have an effect on the solution itself, but the order we choose does have an effect on the difficulty of solving the equation. So as you can see, we have the same equation represented 3 times. I'm going to solve the equation using 3 different approaches, all using inverse and zero product rule. But before we do, we wanted to look at the graphical solution. So looking at the 1 over x plus 2 minus 3 intersecting the line x plus 1/2, we can see 2 solutions, x equals negative 1/2 and x equals negative 4. So that's all accepted, but now let's just talk about the algebraic methods. In the first case, I'm going to immediately try to invert the x plus 2 in the denominator. So by so doing, if this is divide by x plus 2, I'm going to multiply by x plus 2 because that's the inverse of divide by x plus 2. In order to keep balance, I need to do the same thing on both sides. Keeping in mind, x plus 2 is a quantity which must be distributed into the quantity 1 over x plus 2 minus 3. So I have to distribute in this fashion. So that's how we keep everything straight. We show that all 4 terms in the equation are multiplied by the quantity x plus 2. In the first case, the x plus 2's divide out to 1. In the second case, I distribute the negative 3. Careful there, the negative 3. And here I distribute x into x plus 2 and 1/2 into x plus 2, also known as foiling. The rest is a matter of collecting like terms, and since I see quadratic form, I'm going to set the quadratic expression equal to 0, so I can apply the zero product rule. Sometimes we might struggle in trying to factor when the coefficients on the quadratic form are in fractions. So I'm going to fraction bust by multiplying both sides by 2, and now I get a quadratic expression which is going to be factorable, and we'll get to that a little bit later. We're going to look at the second equation now, and this time, instead of applying the inverse of divide x plus 2 right away, I'm going to provide the inverse of subtract 3. That is to say, I'm going to add 3 to both sides. What that does is create an equation where the left-hand side is simpler, and now applying the inverse of divide by x plus 2, I can FOIL and collect like terms and subtract 1 from both sides. And once again we see fraction coefficients, we'll double both sides, and we end up with identical equations. So the choice is multiply both sides by x plus 2 right away, or get rid of the negative 3 by applying the inverse of minus 3, and then multiplying by x plus 2 both sides. Turns out to make the work a little bit cleaner. In the third case, I'm going to add the 3 to both sides, just like I did before, but this time I'm going to fraction bust now instead of later. So I'm going to multiply both sides by 2 here. That gets rid of all the fractions. Now I can apply the inverse of multiply x plus 2, or divide x plus 2 on both sides, and FOIL, and subtract 2 from both sides, and end up with the exact same form. So the purpose here is to demonstrate that we can apply the inverses in any order we choose, but which order we choose is going to have an impact on how easy it is to do the arithmetic. Just to finish off, this quadratic expression is factorable, and in factored form I can use the zero product principle now to evaluate x plus 4 equals 0 and 2x plus 3 equals 0, and we see the same 2 solutions here as we did in the graph, no matter what. One more example, and I'll go through these a little bit quicker. The first equation, or they're both the same equation, but the first method I'm going to use after I look at the graphical approach and find the solutions, the first method I'm going to use is to multiply by the inverse of divide by x minus 4. So I multiply both sides by x plus 4, or minus 4. Left-hand side divide out to negative 1. On the right-hand side, we just have to remember to FOIL. I'm going to collect like terms, apply the inverse of subtract 1 to both sides, that's add 1 to both sides, And now I have to get rid of the fractions to make this easier to factor, multiply both sides by 4. Gives me this quadratic expression. Now, you can see here, my first choice was to multiply both sides by x minus 4, and later on I had to multiply both sides of the equation by 4 to get rid of the fractions. What if I changed that order? What if I looked at this, multiply both sides by 4? In fact, let's take this one step further. This is a negative coefficient, positive, negative. If I multiply both sides by -1, I end up with this equation where we have more positivity and an easier to factor expression. So what if over here I multiplied by -4 on both sides? Basically, the negative is going to get rid of all this negativity down here and take me straight to the end. And the 4 is going to get rid of all the fractions, and I'm doing all of that right off the bat. And that produces this equation. Multiply now both sides by x minus 4, and that produces this quadratic equation. Subtract 4 from both sides, and I'm right back where I started. So I want you guys to understand there's no wrong way necessarily to solve equations, but sometimes there's an easier way depending on the order you choose. So it's important that we think before we act, look at the equation, and try to find an appropriate approach. Again, it doesn't matter which approach you use, but it does matter if you're being so inefficient that you can't finish a test on time. To finish this one off, I'm going to factor and use the zero product rule to get the two separate values for x, which correspond to my graph, as we can see up here. So, thanks for watching.